Last night, astronomers confirmed something that shouldn't exist. A supermassive black hole, weighing as much as 20 million suns, is racing through the cosmos at 2.2 million miles per hour, leaving behind a trail of newborn stars that stretches farther than the width of our entire galaxy. This isn't science fiction. This is the universe showing us it's far stranger than we imagined. Welcome back! For nearly 3 years, scientists have been staring at what they thought was a camera glitch. A thin streak of light in a Hubble image, so unusual that Yale astronomer Peter Van Dokkum almost deleted it. He was searching for globular star clusters when he noticed the anomaly. His first thought, cosmic ray artifact, a technical error. But when they ran the analysis again, the streak was still there, brighter, more defined, and completely unexplained. What Hubble discovered in 2023 was extraordinary. What the James Webb Space Telescope confirmed this January is revolutionary. We're looking at the first verified runaway supermassive black hole in human history, and the implications reshape everything we thought we knew about how galaxies live and die. The numbers alone are staggering. This cosmic monster travels fast enough to cross the distance between Earth and the Moon in 14 minutes. That's supersonic on a scale our minds weren't built to comprehend. But speed isn't the most fascinating part. As this black hole tears through intergalactic space, it's not consuming matter like we'd expect. It's creating it. Behind it stretches a contrail of young blue stars, 200,000 light-years long, twice the diameter of the Milky Way. The black hole is moving too fast to feed, so instead of devouring gas clouds, it's compressing them, triggering star formation in its wake. Van Dokkum called it unprecedented. Nothing like this has ever been observed. The story gets darker. Follow that stellar trail backward, and it points to a galaxy 7.5 billion light-years away. A galaxy with no active black hole at its core. Think about that. Every major galaxy we've studied has a supermassive black hole at its center. It's gravitationally locked in place, the anchor point around which hundreds of billions of stars orbit. But this galaxy's anchor is gone, ejected, thrown into the void by forces so violent they defied conventional physics. How does something weighing 20 million suns get expelled from its own galaxy? The answer involves what scientists call galactic billiards. Picture this: two galaxies collide approximately 50 million years ago. Each carries a supermassive black hole at its heart. These titans begin orbiting each other, locked in a binary dance that warps space-time itself. Then a third galaxy arrives with its own black hole. Three massive objects, chaotic gravitational interactions, unstable configuration, and according to the laws of celestial mechanics, one must leave. The math is brutal. One black hole steals momentum from the other two and gets launched into intergalactic space at incomprehensible velocity. The remaining binary either stays intact or one replaces the other, kicking out the original companion. Either way, you get what we're seeing now: a rogue black hole racing away from its birthplace, never to return. But here's where it becomes personal for those of us who lived through the Apollo era. When Hubble first captured this image, most scientists were skeptical. The evidence seemed too strange, too coincidental. Van Dokkum needed confirmation, something definitive. So his team turned to the James Webb Space Telescope, the most powerful infrared observatory ever built. Webb's mid-infrared instrument revealed what Hubble couldn't capture: a bow shock. A shockwave of superheated gas at the leading edge of the black hole, compressed by its supersonic passage through space. That bow shock was the smoking gun. Undeniable proof this object is exactly what it appears to be. Think back to the 1960s and 70s when we first started understanding black holes. Stephen Hawking's theoretical work, the discovery of Cygnus X1. Back then, these objects were purely mathematical curiosities. Now we're watching one flee its galaxy in real time, creating stars as it goes. The universe you grew up studying has revealed itself to be even more dynamic, more violent, more creative than anyone predicted. NASA's upcoming Nancy Grace Roman Space Telescope will search for more of these runaways. Machine learning algorithms will scan millions of images, hunting for similar stellar streaks. Because if we found one by accident, how many more are out there undetected? Van Dokkum believes there could be dozens, perhaps hundreds, racing through the cosmic ocean between galaxies. Each one a remnant of ancient collisions. Each one a laboratory for studying physics under the most extreme conditions imaginable. What strikes me most is the timeline. This event happened when the universe was roughly half its current age. The light we're seeing left that galaxy before our solar system existed, before Earth formed. The stars in that 200,000 light-year wake are already middle-aged by now. Some may have died. Others might host planets. Entire civilizations could have risen and fallen in the time it took that light to reach our telescopes. So here's my question for you, and I'm genuinely curious about your thoughts. We found this runaway by pure chance, a lucky accident while searching for something else entirely. How many similar objects have we missed? Could our own Milky Way have experienced such a collision billions of years ago? Could there be a missing black hole from our galaxy's past, now drifting somewhere in the darkness between Andromeda and the Virgo supercluster? Share your theories in the comments, and if you think the universe still has mystery